This is Ralph Brandt from the Fireside. We're reading from the book Christy, Injured in Space. We'll be reading Chapter 2, We Have a Problem. Inspection of the damaged shuttle started as soon as all volatile fuels were drained and it was pulled to a hangar. When they opened the left environmental system bay, they found what appeared to be sabotage. An access port to the third manifold in the main ECS handling system had blown off, opening the cabin to space. Bolts that held the plate in place were missing. An inspection of the threads in the bolt holes showed no damage, but the threads contained plastic. The steel bolts had been removed and replaced by plastic bolts to hold it on. These held for small pressure differences, the ones used for testing, but when the larger pressure differences of space occurred, they blew out. The bolts failed when the outside pressure decreased and the pressure under the plate exceeded their strength. The plate was a projectile that damaged wiring to the controls, preventing closure of the valves to the cabin. It was clearly sabotage. It wasn't a mistake. Worse, an inspector may have easily missed the different bolts. The bolt heads were found in the bay. They had been painted to look like metal. That confirmed the action as sabotage. A check of the right bay showed the same change to the SECS. Cindy's decision to not attempt cabin pressurization using SECS was crucial. The output of each ECS system went to a system of valves and manifolds. The first manifold fed the suit connections and the second manifold. Each manifold output had a valve. The second manifold fed the airlock, and had Cindy opened the valves in the second manifold to the third, and the cabin valves, the third manifold, in an attempt to pressurize the cabin, it would have blown and damaged the SECS. The plastic bolts were still in the third manifold. The FBI was called in to investigate and the shuttle was placed under guard. A complete inspection of the shuttle was put on hold until the FBI could do background checks on the people who would be doing the inspection. Anyone who might have had access to the shuttle systems was suspect. All had been cleared before they could be near a shuttle. Some situation had obviously been missed, or someone got access who shouldn't have been there. Teams of FBI agents were given security videos, access logs, and pictures of employees. Every person who entered any area of the complex had to be identified and logged. IDs were verified and re-verified. The tapes were reviewed. Every person who appeared on any tape had to be positively identified. Nobody was allowed with the shuttle or videos alone. There was a significant security problem and they did not know where it was. Everyone was a suspect, including the FBI agents. On the station, the evening was spent getting the suits, tools, and parts ready for the next day. Everything was checked and placed in the various packs they would use. The items were stowed next to the airlock in preparation for the EVA. The next morning, they were ready to begin. Without the shuttle arm, they could not move the lab. Even in a weightless environment, a 10-ton module has mass and inertia. But the plan the engineers devised was simple. The new module had its own power supply, maneuvering rockets, control unit, and supplies. A small rechargeable battery was keeping the transponder and some of the environmental systems operating. Unless connected to the station power, this battery would die in a couple of days. This would complicate the latter work. If they could connect the main station power supply to the module and connect the power and network in the module to the power and network in the station, it could supply power and the onboard crew could control the thrusters to move the module. The network cross-connect would be by a fiber link between the two craft. Christy and Don would do an EVA and connect the fiber patch cord between the network ports on the outside of the module and the station. The power would be supplied by what amounted to an extension cord. With the power and control established, they would guide the rocket firing to bring the module into position. With the module in place, they would secure it to the lattice of the station and mate the ports between the two units. With that done, they could pressurize the module and open the doors between the units. Once there, they could begin the work of bringing it online. The supplies and tools they would need were moved to the airlock. Don and Christy donned their EVA suits and started pre-breathing. Kim prepared the fiber for the connections to the network, then prepared the extension cord for power and put them in the lock. Don and Christy entered the airlock and prepared for the EVA. When they got outside, they carefully routed the fiber and power cords so they would not snag when the module was moved. Christy made the fiber connections. Don connected the power. Larry was programming the handheld controllers to fire the thrusters. With that done, the two spacewalkers entered the module. It took 3 hours to power up and test the necessary equipment. They returned to the airlock to recharge their suits and get additional supplies. Back out in space about 20 minutes later, they took positions near the module so they could watch Larry test fire the thrusters. One by one, he fired them at low settings to verify the programming. Christy and Don could see the plumes of gas spew from each thruster. Together, they connected the cables that would tether the module. In the event something went wrong, the module would not just float off in space. These were just connected to the module and a member of the framework that was part of the original station. When they finished connecting the new tethers, they released the short tethers they put in place the day before. Larry Roth began the rocket firings, slow, low power, and very short at first to gain a feel for the process. The module must be moved a few feet away from the station, turned 45 degrees, and inserted into one square of the lattice that was the station. It could not be allowed to bump anything. As it was inserted, they must guide it until it reached the airlock at the end of the current structure. This lock was shaped like a kid's jack with 6 points. Each point was the connector for a module or corridor. At the current time, there were 5 modules: the main control module, the service and supply module, and the engineering modules were on 3 points of the jacks. The science module was connected to the end of the engineering module. The service and supply modules were really 3 segments that were brought up at one time. They were connected in line. The diameter of the SRB for the shuttle was limited by the size of the railroad tunnels from the Thiokol plant. The maximum size and weight of the module was limited by the size of the cargo bay of the shuttle and the lift capacity of the shuttle. The sleep module was connected to the last one of these service and supply modules, placing it as far away from the sources of noise as possible. Although noise is not transmitted in a vacuum, the metal hull of the modules did a superb job of conducting it. Sleep was not easy if the station had more than a few visitors. With the new modules coming up, the number of visitors was down. The crew was somewhat of a skeleton, with only the 2 landlords, as they were called, and 4 people who were working in the science module. The assembly crews were kept to a minimum to reduce the expenditure of supplies. A second service module, string, and sleep module was planned to connect to the new module to provide what is called a diverse backup, a module that would be unlikely to be damaged if something happened to the other service module. A second airlock and sleep unit would ultimately be installed behind it as soon as they could be brought up. With it, a direct conduit tunnel between the locks would be installed to allow another path through the station. Right now, all 6 doors of the airlock were closed. This was a normal mode when work was being done. It isolated the modules in case of a problem. Don and Christy moved the module into position and secured it to the airlock. Don finished the bolts connecting the module to the airlock, collected the tools and supplies, and headed for the EVA airlock. He came inside, transversed the module to the main airlock, entered it, closed and secured the doors. Christy was on the other side finishing the inside connected. When she finished, she jetted to the open door, tethered herself to the loop outside, closed the door, and moved to the joint with the airlock. She checked off each bolt, verifying that they were properly tightened with a torque wrench. This procedure was clear. One person inserted and tightened the bolts. The other verified that they were tightened. A failure of this connection was considered a LOVE, a loss of vehicle event, a euphemism for the whole thing blew up. Don was now beginning the protocol for pressurizing and opening the access to the module for the first time. He overpressurized his suit to verify its integrity. It was still pressurized. Again, this was standard practice. The last thing on Christy's list was opening the access panel and checking the levels of the consumables in the module before they continued to power up. She jetted around the module to hook up the station systems to the consumable bay. She put her feet into the grate provided to make work there easier and locked them to remain steady. She attached the tether to hold her to the station. As she opened the latches to the bay, an explosion blew the lower portion of the panel back into her legs just below her knees. This is the end of Chapter 3 of Christy, Injured in Space. Thank you for joining us. This is Ralph Brandt from the Fireside.